Good morning, season's greetings, and a special thank you to all of you for taking your time today. My name is Jeff Elder. I am the General Sales Manager for Interstate Brick and HC Muddix Brick Companies. I am a licensed structural engineer and a LEED accredited professional, and I've worked in the industry for 25 years. And I am an avid supporter of BIM for Masonry and look forward to visiting with you today. I will be one of the presenters. With me, sounds like there's a few people trying to join in.
Please enter your audio PIN followed by the pound or hash sign.
With me today is Russell Gentry. He is a lead developer for BIM Masonry. Russell is a professor and a structural engineer at the Digital Building Laboratory of Georgia Institute of Technology in the School of Architecture. Dr. Gentry received a bachelor's and master's degree in civil engineering at Georgia Tech. He went on to receive his doctorate of civil engineering of structures from the University of Michigan in Ann Arbor. And Russell, thank you for joining me today. Georgia Tech was selected to help the masonry industry create a strategic plan to develop and implement BIM for Masonry software, intended to unify the masonry industry, create smoother workflow, and collaboration across all disciplines involved in the use of masonry, from owners, manufacturers, architects, engineers, masons, and general contractors. And Georgia Tech performed this action for the American Institute of Steel Construction and the Precast Concrete Institute. And with him today, Tyler Wittoon is also joining us. Tyler was a recent employee with NCMA and has since left to get his master's degree at Georgia Tech. He will be taking your questions and we'll be responding to them. Directing this activity, but not on the phone with us today, is David Biggs. David Biggs is a structural engineer. Many of you probably talked with him or heard his lectures regarding BIM-M. He is with Biggs Consulting Engineering in Troy, New York, and the technical director for Constructive LLC, a masonry technology development company based in Detroit. He is a distinguished member of the American Society of Civil Engineers and an honorary member of the Masonry Society. David specializes in the design and restoration of masonry structures and forensics engineering and works internationally. He currently serves as the program coordinator for this initiative, the North American Initiative for Building Information Modeling of Masonry. That's what the official title of BIM-M is. We are fortunate to have his support as well. You'll notice that the microphones have been disconnected for this presentation, but we hope you'll write in your questions. As you write in your questions, if it's a question for me, put Jeff in the front of it, and if it's for Russell, you'll start with his name and then ask the question. We're going to hold off on answering the questions until after the presentations, just to make sure we get through the information that we feel is important. And then hopefully that will answer most of your questions, but if not, we would love to help out. And we've limited ourselves to an hour, but if you have questions and want to ask and stay on the line, both Russell and I will be available for continued questions for about a half hour after that. BIM 101, what is BIM? What's in it for me? Probably the biggest question is, how's it going to make me money? And I think that's why you're all on the phone today. One of the problems with BIM is that there's really two different definitions for the acronym BIM. One is building modeling. It's a digital representation of physical and functional characteristics of the facility. What that means is everything involved with the building three-dimensionally is being considered here. It's 5 dimensions. That's one of the things that BIM actually creates a unique advantage for us. It allows us to see buildings in space, in X, Y, Z space, but it also gives us the ability to track time and to track money. And all of those things have been very important when you're building masonry buildings. One of the complaints is scheduling, getting material onto the job site and off and in the wrong spot, and coordination of those efforts. Interoperability is a name that we don't all understand very well outside of the industry, but it's the ability for all of the design software used by connected industries to communicate in all those 5 dimensions, back and forth, completely and accurately. And that's not happening, and we'll get into that in a few minutes. Clash detection. This is where you can build a wall in 3-dimensional space. A mechanical engineer puts a plumbing or heating duct through your wall, and it creates a conflict. Maybe it's right through a beam, or it's through reinforcing. And so this allows a contractor to go in and be able to identify clashes. Something pops up on the screen, says there's a problem here, and it allows us to evaluate before we ever start construction and eliminate expensive change orders. Virtual construction is the ability to look at these items graphically before we physically build them, so we can go in and identify what's going on in a building. And then the parametric, this is where everything that goes in, every 3-dimensional model, every beam, every wall, every brick, everything is sized in space compared to all the other materials. So when you do a 4 by 8 brick, 3 5/8 by 2 1/4 and 7 5/8, it's actual compared to the rest of the building. So it has perspective. The other BIM, Building Information Model, is a 3D representation of the individual components in a facility along with all the essential data. And this is where we've kind of gotten conflicted as an industry. We've been led to believe that this is BIM, but it's not. It's only a portion of it, and I think that's where some of our problems are. The perceived goal in the industry was to create models and to fill out a database. We did this almost 10 years ago as a company. We expected that Revit would be able to take our models and be able to take the data and import those, which it does to some degree, but it's very limited. But the problem is Revit might be able to take advantage of that information, but the structural engineering package can't, the mason contractor package can't, the mechanical and electrical engineering packages cannot read the information, and they can't transfer information back and forth from say the structural engineer back to the architect, and the architect back to the structural. So the perception was that the software is available and interacts with all industry groups, but it doesn't currently do that. And yes, we need a comprehensive and consistent database with models, but that's only a small portion of it. We are developing multi-layered spreadsheets with all the data tied to 3D images. That is part of what BIM-M is going to be doing. It's part of one of our projects. In fact, it's what I oversee. Then there's the 3-dimensional images in space, and yes, it'd be nice not to have 1 million of these from 200 different companies, but what we want to do is reduce and somehow unify our industries so that we can communicate with the architects and engineers. And our biggest goal of putting BIM together, BIM-M, as we call it, is to create unity. It's the first time. I've been with the industry for 25 years, and this is really one of the first times, I think, collectively between the concrete, the clay brick, the mason contractors, and the general contractors, architects, and engineers, that we're trying to become more unified. We want to produce, sell, and install more masonry. That's ultimately the goal. If we don't accomplish that, then we've wasted our time. We believe that that's been very successful for the steel groups and for the precast concrete groups. They have some unique advantages over us, and we would like to tap into that. We want to make masonry more competitive. Part of doing that is eliminating some of the activities that we do 2 and 3 times because we don't have the software communicating. The easier to design software, where ultimately the goal would be, and I know this is not possible, but conceptually it would be to push a button all the way through the process and have a building constructed. Now, that's wishful thinking, but we need to get closer to that. We need to eliminate waste of materials, manpower, time, and money, and better coordination among everyone involved. To give you a little bit of help understanding what BIM-M is, and BIM and Revit and all these names that we hear thrown out, I wanted to give you a little history. The first is to take you back to where we were doing line drawings. When I first started, we sat in front of a table with a sheet of vellum, piece of paper, started drawing lines on end, and that tried to represent a building wall, footings, foundations, floors, and so on. And we would do renderings, sketches, so people could look at this three-dimensionally. And then we got sophisticated and created drafting tables and rulers and triangles to help us with that. We started layering our sheets. We would line up all the dots representing grids and dimensions that were unique and part of the project. We layered those, but they were sheets, and each sheet represented floors or footings or some different elevation on or height on the building. Then, with the advent of computers, we were able to create two-dimensional drawings that were graphic representations of what we had been doing with line drawings on sheets of paper. But they were still basically electronic sheets of paper. They were just thin layers. There was no dimension to them. And from that, as we started getting larger and larger computers with greater memory, we had the ability to put in more points, more data information, and we now get what we call computer-aided design, three-dimensional models, where we can actually walk inside those buildings, we can walk inside the walls, we can look up in the ceiling, we can actually start placing materials, cabinets and flooring and all types of things to create three-dimensional models in real space. But until we start adding actual dimensions, in the past with Revit, what we were really looking at with brick, even though we had three-dimensional models, is they were just lines on a sheet of paper. We're not looking at individual brick or block units with coring and reinforcing and grout. It just represented two lines representing the width of the material, and we'd have an airspace, cavity walls with ties and so forth. But the software really didn't have the capability of putting all of that together and keeping track of it. And that's what we're in the process of trying to put together with BIM-M. It's the building information modeling of masonry, embodies all of the preceding goals that I just put together. BIM-M is the development of the individual model, the software, the interface with all the facets of design, fabrication, construction, of masonry, the materials, the building, the coordination, from cradle to grave. So, and we want to even include maintenance, long-term maintenance, because with life cycle costing, we need to be able to put materials and their longevity, their durability, sustainability, so that we get greater advantages. As you know, one of the things that we try and say with masonry, it's 60 to several hundred years in durability. We never are able to take advantage of that. So BIM-M is one of our goals, is to make that happen. So the initial task, and Russell will get into this a little bit more, was to determine, when we first started putting BIM-M together, what's available out there. What do we know? What data is available to, say, the software companies, Revit and others? What's the information that's missing? So we developed a roadmap. We looked at the projects, who's involved, how's it getting done. We considered the workflow. That's part of this second phase, the owner to the architect to the engineers, and so on. The first project starts with the units. That's where I've been involved in trying to coordinate the concrete masonry and the clay masonry and the cut stone and manufactured stones and concrete pieces that go into the masonry building. What do they look like? What are the specifications? Can we create a database of information that can be used for Revit, for the structural engineering software? Even though Revit is the software that kind of puts their names out there are many others. I mean, there's Vectorworks, there's SketchUp, there's SolidWorks. And the goal isn't to favor one of these companies directly. It would be to get software in a form or a format that every company uses, and they're used to grabbing the information and sending it back and forth to each other through the same stream, if you will. And I'll show you that in a second. We've got projects where the architects are looking at the building types. What are the architectural and engineering needs? What's the unit information, the data that they need to design their buildings? Then it will look at the manufacturers. How is the information coming to and from the manufacturer? Is it coming from the architect or the engineer? Is it coming from the mason contractor? What information do they need? When do they need it? When do we need the information as manufacturers that we're looking for? So all of this cuts down on time, and it saves on money and duplication. And so we're looking at the workflow and the software modeling as part of projects 2 and 3. This is, when we talk about interoperability, this is kind of the confusion that we look at. And I tried to do a diagram to show you. Everything, as you see, the arrows are going one direction. The information comes from the architect, it goes to the manufacturer, the engineer, the GC, or the mason, but nothing comes back directly through that same channel. For instance, some of you have been involved. If you're a mason contractor, you may use the software Tradesman. What happens is the architect draws his drawing in Revit, but because Tradesman doesn't have the ability to read that software, the mason contractor has to redesign, redraw all the building walls. We have to do shop drawings where the architect or the engineer could have put that, the information's there, the walls are there. Why not have that software create the shop drawings? The wall elevations. So the mason contractor doesn't have to hire 1 or 2 guys to drop wall sections where this information is coordinated back and forth. This is what we're looking at. We're looking at, this is interoperability, is for, you see those arrows are connected. The information can go back and forth from one individual or one company back to the other. and that information stays there. So the structural engineer has to change a wall thickness. When he sends it back to the architect sees that immediately. The walls are automatically changed. The mechanical engineer gets that information, sees, if he puts a pipe through your wall, you see that information. So we eliminate a lot of the problems that we currently see in change orders and conflicts where we're all trying to refix the wall. Under the first project, when we look at the model, we're looking at, first off, and this is Smart BIM. This was their library. This happens to be something that Interstate put together, but we had different wall types, the objects, the different wall systems, and then you can see on the far right the properties of the material. And the problem is the information that might come from us might come in a way that's a little bit different than maybe it would come from another manufacturer. Even though we have wall sections and everything else, we need to keep the data consistent. The old adage, junk in, junk out. We need to somehow coordinate this, and that isn't in the system right now, and that isn't what the first BIM or what some of the manufacturers were trying to accomplish. So here's what we're looking at. We've got the masonry unit model definition. We have clay masonry units. We're looking at the suppliers, their data, the prototypes, the models. We have this database of information, which isn't complete. It's going to be multiple sheets with information representing every manufacturer. We know every manufacturer wants to have their own specific data in there, and that's important. But we also need consistency. We need to be able to tie together based on what the architect or engineer is going to need for their project. Same thing for concrete masonry, separate database for them. And we have the cast stone units. They have their own database specific to them, and we would be able to do that for each material type that we feel is important to add to the system. Project 2, which is also is going to be started here shortly, is they're in the process of trying to come up with wall types and building types that we will analyze first with the software to make sure that the software is functional and that it's getting information back and forth as has been discussed. And then this workflow. How does it get to every aspect of the project to make sure that we build buildings, first graphically and then physically. Phase 3, specifications, create the specs for each of the materials, develop structural BIM tools, analyze construction workflows, and then complete the contractor input. Then phase 4 would be implementation of the specs, the construction design, architectural design, and then some training. And the goal is to have that completed by June 2017. And I'm going to now turn the meeting over to Dr. Gentry. Russell?
Thank you, Jeff. Jeff, can you hear me?
Yes, just fine.
Okay, I want to remind you that Tyler Withune here at Georgia Tech is online and is going to be addressing questions. So if you have questions, as Jeff said, please put them in the little question box and either put Jeff or Russell in the top, and we will try and answer questions at the end of our discussion. I want to thank Jeff for his leadership on this first project, the Model Unit Project, and he represents all of you on the manufacturer's side. He knows what it's like to make brick and block and sell these materials, and to try and answer the questions that architects and engineers have, and to put your material out in the marketplace in up against competitive systems, and so he's been a great advocate for you in the masonry supply industry. And I report up to the executive committee of BIM-M through Jeff. So if you have concerns about the kind of management of the masonry materials project, please let Jeff know. And of course, Jeff rolls up to David Biggs, who has done a tremendous job of representing the industry, and a lot of the cohesiveness that's coming from the BIM-M project is coming because of David's leadership. Here at Georgia Tech, I'm leading this project. My colleague Chuck Eastman, we call him the godfather of BIM. He's been working in this area for 35 years, back before a computer had a mouse. And then we've got a group of young graduate and undergraduate research assistants. Tyler Watoon, Shani Sharif is a design computing PhD student who's going to be joining us in January, and Weston Landis, who helps in many aspects of what we do. Georgia Tech is the contractor to BIM-M, so we are paid to do this work for you, and I'm happy to hear from you, whether it's kudos or a tomato. I want to know how we're doing and how we can do better. Have to acknowledge the support of all of you through your industry trade associations. It's primarily the main industry trade associations in the masonry industry are supporting us through the Charles Pankow Foundation, and the partnership with Pankow is win-win because they are widely recognized across all areas of design and construction research as kind of leading applied research and construction. So our affiliation with Pankow is important to all of us. And you may or may not have read the roadmap, but you may at least be aware of our kind of overall graphic idea of how we're going to move ahead with BIM-M. And we're here in this early phases of early part of phase 2. And the only project that started so far formally is the Masonry Unit Model Definition Project. I guess that's not specifically true because the Masonry Wall team working through the Masonry Society is working pretty hard at putting wall definitions together. So I misspoke there, but we at Georgia Tech are not working on this project yet. We're concentrating on the Masonry Unit Model Definition, and that's what we're going to be discussing today. So what do I mean when we say Masonry Unit Model Database, or MUMD, and why do we think that we need one to support BIM? And we say that there's a number of reasons. First, there's a lack of common nomenclature for masonry units. There's no common electronic product data catalog, so everyone has their product data, but it's all in a different format. This makes it difficult for architects to compare units. In terms of your internal process in your business, you may or may not be easy to track the units within, say, MRP systems within your business, and then to use that data to help the people who are buying the masonry from you, your supply chain. And it certainly is difficult to instantiate masonry and BIM in a way that supports design. That's our primary focus. So what are we doing at Georgia Tech? We're developing a formalized understanding of user needs for information regarding masonry units and systems. And I'll try to make that more clear as we go through the presentation. We're surveying the industry. Jeff is leading this task. We are trying to gather as much information as we can, both through Jeff's process with you as well as our own process in looking at what's available publicly about all masonry information. We're building, if you will, a small data model internally for each of our objectives in the project, and querying that model virtually to understand how we might better represent masonry information. And we're developing workflows, and I think Jeff did a great job of talking about building information modeling workflows, and I want to talk about that more in just a minute. So if we look at our process at Georgia Tech, we're looking at the design and construction process as a whole, and then we're developing process models whereby we are capturing who needs to know what at what part in a given process in construction. So I'm going to give you a very specific example in a minute, but we're looking at the handoffs of information from, say, a masonry distributor to an architect, and then how that masonry distributor communicates with a given masonry manufacturer about whether a certain product is available, and, for example, what is the minimum order quantity and lead time for that material. So that's a flow of information that currently today is ad hoc and person to person. But in the BIM-enabled world, we would imagine that some of that information could flow in an automated and digital way. So we're developing the process models and the data models to support those workflows, and then through some metrics trying to assess whether such a BIM-enabled process would save money, save time, or make masonry more competitive. I know it sounds complex and technical, but I hope through the examples that I'm about to show you it becomes more clear. We've been given what I would call the top 10 units from each of the industry segments: clay, concrete, and cast stone. And so we're using these to think about our process and automate some of our design models. Again, we've gotten information from Jeff in these huge spreadsheets about geometric and material property data about masonry units. And we're developing these complex entity relationship models, which are essentially the precursor to a relational database. In other words, to go from a spreadsheet to a relational database, you have to have a data model. And this entity relationship modeling is just one way of trying to imagine how the information could be organized. And we are looking at everything that you say about yourself. So we are looking at every website we can find, from the NCMA membership, the BIA membership, from the cast stone industry membership. We're looking at the information that you have online, which clearly you feel is what you need to get in front of your clients, and trying to understand what a data model that can represent all of this information might look like. And I think it's also important to say what we're not doing at Georgia Tech. Our project is not focused on your internal data models that support manufacturing, inventory control, and order processing. So if you're using an SAP system or some other enterprise resource planning system internally, that's not really our business here at Georgia Tech to tell you how to do that. I would hope that in the future there could be links between the external view of your masonry products that you give to architects and engineers and your internal product data that you use for manufacturing, but that's got to come in the future. And we're not dictating the structure of the data to the masonry supply community. It's not our goal to promulgate a data standard without your input. We're not dictators. We're really trying to collaborate and improve the data models so that BIM can work better with masonry. We are not at Georgia Tech going to be instantiating all of the masonry data into the database. That's not our task here. If we are successful in developing a data model, then we would imagine that you would maintain your own data, that you need to be able to maintain and update your data. I think Jeff made a statement about junk in, junk out, and the actual process of maintaining your product data. I know that you are all probably frustrated by this process already because you have information which is internal to your company that might be embedded in PDFs, that's on your website, that you've put in BIM models that are being hosted by Autodesk Seek or Smart BIM, and I would guess that there may be some inconsistencies across those four pools of data. So managing that data is a difficult process. We're going to talk about it in our final report to you, but we recognize that you, as the masonry suppliers and manufacturers, are going to have to maintain that data. We are developing scenarios for computer applications that will use this new unitized masonry data, but we're not developing software here at Georgia Tech. We're writing a software specification, and we hope that companies like Smart BIM and Autodesk and Tekla and others will take our software specification and implement it. So that's the future hope for BIM-M. And we won't host the data on our servers here at Georgia Tech. Again, that's a larger decision that has to be made in concert with the building products industry. So what does the masonry unit model database look like? We envision it as a data hub in the middle, and then depending on our need to know, to our stakeholder needs, that people move in and out of that data along different trajectories. And we have identified 9 workflows, 1, 2 through 4, 5 through 8, and 9 workflows that we're going to talk about today to demonstrate how people might use masonry data. And then on this other left-hand side of the figure, of course, we recognize that somebody is going to have to be managing the data and populating this database, and that's yet a separate task. But what we want to talk about now are our stakeholder groups. So let's look at these 9 workflows. First, I'll just say this is the one I'm going to illustrate today in some detail. How does an architect, owner, or client access information through the masonry unit model database to decide what sort of masonry they want to use on their building? And then we imagining an application, in this case a web application or a web portal, that ties the stakeholder group to the database. So the 9 workflows, as shown on this figure, are as follows. First, the architectural material selection, where you can imagine early in a project, people are saying, I want to use brick, or I want to use an architectural split-face block. What is that going to look like? Where do I get it? How much does it cost? What's the lead time? What color grout does it work with? So those are the sort of questions that are being answered early in a process. And as we go through all of these workflows, you can see that they are specific to different moments in the design and construction process. So I'll quickly run through the 9, and these are likely to change, and there may be even more as our process evolves. But the architectural material selection is the earliest process where you're trying to sell your architect on using masonry. The architectural design modeling phase, number 2, is when an architect generally is developing the form and massing of the building. Very early along, they're using software like SketchUp and Rhinoceros to develop quickly evolving models of what the building might look like. Generally, these workflows are pre-BIM and pre-Revit. In workflow number 3, the kind of form and size of the building has taken shape, and we have the architects beginning to instantiate their model into Revit and competitor packages to build a true BIM model. And then in workflow number 4, collaborating with structural engineers on load-bearing masonry and even in non-load-bearing masonry to carry the wind loads in the facade, so that 3 and 4 are tied together as kind of a joint workflow between an architect and a structural engineer. As the project moves on in time, we have quantity takeoff and cost estimating, and we can imagine that the data model can be tied to software like Tradesman, widely used in the masonry industry, later on to masonry project scheduling, and material procurement and tracking, because we know that when masonry is sourced. The masonry may be bought out by one masonry supply company, but that masonry may come from a number of different sources, a number of different manufacturers, and so the supply chain management during the construction process is important, and that's workflow number 7. In workflow number 8 in construction BIM, what we can imagine is how do we supply information on site to masons and the mason contractor, the boots on the ground, in terms of where is the material, when is the grout arriving, are there any special units which might hold up, what is the coordination with other trades. So these are specific workflows that take place during actual construction. And finally, as Jeff mentioned, we recognize that BIM is going to be a really strong tool for facade evaluation and maintenance. And we already see architects trying to embed condition assessments in BIM, and so that will be yet another workflow which we're going to consider. And finally, I have a note to myself and to you at the bottom of this slide is that we have to consider both what I would call standard masonry workflows, where the masonry units are off the shelf, if you will, typical brick and block, and also custom masonry workflows, where the masonry units are either cut or cast for a specific project and require much more iteration between architects, engineers, and the manufacturers in terms of geometry, shop drawings, even things like shop tickets used for the production of formwork. All of those are BIM-enabled workflows, and so we will have to have specific kinds of ideas about workflows in that aspect of the industry. And it's important that we need an energy analysis workflow as well, because in these early stages of architectural design modeling, in sophisticated architectural practices, almost all buildings are undergoing energy modeling early in the design phase. And we want masonry to be easy to analyze, and also for the thermal mass advantages of masonry to be well instantiated in BIM models. So let's talk briefly about this architectural material selection workflow. And what do we do at Georgia Tech to diagram that workflow and then understand what the data requirements are? So as we visit architects' offices, the traditional masonry samples still proliferate in commercial architectural design. There are still material reps in the channel who are calling on architects and getting the samples into architects' office. And this is still a significant part of the design process in architects' offices. I want to spend a fair amount of time with this diagram. I know this diagram is a little bit perhaps complex, but I think for those of you in the masonry industry who are going to collaborate with us at Georgia Tech, this is a tool that we use to try and understand how information flows and what information is needed. And this is a standard notation called BPMN, or Business Process Modeling Notation. And in this diagram, we see 3 swim lanes. We have the architect from left to right. We have a masonry materials distributor from left to right. And then we have a masonry materials producer from left to right. And so we see the process, the business process of deciding and selecting masonry to go on a building. So if we see the start of the process is here with the little green circle. The architect is browsing web pages. They're looking at your web pages, and they tell us, architects tell us, that that's their primary first sources of information about masonry are the web pages that you keep, and also all of the materials that they have in their material library. So this is a traditional process of looking at materials, right, touching and feeling them. This is important to architects, as well as looking at the size and family data that you have on your web page. And this web page is tied by a link to the masonry unit model database. In other words, we would hope that in the future that the model data is what is used to develop the web pages, so that if you update the model data, the web pages are up to date. Right now, a lot of web pages aren't up to date, honestly. So at some point in the architectural process, the architect is going to want a sample board. And a sample board represents the masonry units, the range of masonry units and mortar colors that the architect is thinking about using. And the architect will request a sample board from the local distributor, from the local product rep. And that product rep may represent one or more masonry companies. So they're going to negotiate with the masonry producers to determine what the most likely masonry units are and mortar colors are to fulfill the architect's needs. So the product rep is acting here as an intermediary between the architect and the producer of the masonry. There's almost always a process of dialogue between the product rep and the architect to refine the design idea. And finally, a sample board is created at the distributor's office, and that sample board is received by the architect. So these are just larger versions of this. I won't spend more time, but we can see here where the architect starts. You can see the connection to the masonry unit model database. You can see the process through which both the distributor and the producer work. Notice I'm showing another data element here. This is the enterprise resource planning data. So this is what you use within your masonry manufacturing process to determine stock and availability, manufacturing, raw materials. So this is the business process modeling notation. And we're developing one of these diagrams for each of the 9 workflows that I presented earlier. And each of these diagrams help illustrate the different types of material data, material property data and availability data, color, texture, size, that are required at different stages in the design and construction process. So finally, here's the sample board that gets delivered to the architect's office so that the architect can decide, is this the look and feel that they want for this building? How many of these get delivered before a decision is made? What is the cost to you as the distributor and the manufacturer to produce these boards? And can you imagine computer applications like the existing masonry designer that better facilitate this process to cut down your costs and the lead time associated with interfacing with the architect? So again, this is just one of the 9 postulated workflows. But what about BIM? So many of you are already supplying BIM data, primarily in Revit. The primary repositories of this BIM data are Smart BIM here in Atlanta and Autodesk Seek. And we're looking at your data, and we would say that the quality of the data varies widely, and it is not well structured to support the workflows that we've identified. But this is not necessarily your fault because I think in this last bullet, much of this can be attributed to incomplete BIM modeling. That is to say that the BIM models that you're promulgating may or may not have the attribute data embedded in it, but most of it is due to the limitations of the current BIM modeling software. So Revit doesn't really represent bricks, it represents walls, and so it's tough to tag a brick when the brick doesn't really exist in the internal data model of Revit. And so that's yet another task that we have overall in BIM-M, is improving the data model for walls. But I would also make this 4th bullet point here strongly. I would say that in general, the workflow for you, that is the masonry suppliers creating BIM data, has not been established in a way that it can be easily updated. And so many of you created your BIM data as kind of a one-time exercise, but I'm not sure that you've got a process in place for managing and updating that BIM data and understanding when it might be time to revise it. So we've looked at your BIM data. This is just a screenshot from Endicott. Here, for example, and I'll run this pretty quickly, is how an architect might access your BIM data. This is some BIM data from Boral Bricks, and this BIM data is hosted through Autodesk Seek. Autodesk Seek is a building information modeling repository. It's actually it's been developed to be a profit center for uh, uh, Autodesk, because what they're going to be doing is building BIM data for product manufacturers like you, and then hosting that data on their website. And hopefully, you know, what Autodesk would tell you is that by them building the data and hosting the data, you have the best hope that the data is valid and unified in a way. So what we see here in Revit is this Boral BIM data. They've populated about 30 different wall types with both modular and utility bricks and different mortar colors. And then they've put a small, what I would call, patch of that wall in Revit. So there's a 10-foot by 10-foot wall, all in running bond. And there's some attribute data that's tagged to these bricks, including the color, the mortar color, and then there's additional attribute data. Where was the brick produced, both in terms of the zip code and the GIS coordinates. This would be used, for example, as part of the LEED rating system. And then the size of the individual bricks, the weight of the brick, and then there's something about the cubic foot of the brick, but I think this is a place where the data may be inconsistent. But again, the size of the brick is an attribute tag. It's not actually part of the model itself. It's basically part of a spreadsheet that's tagged. And so you can imagine how many hundreds and thousands of wall types that architects imagine. And so you probably don't want to develop all this BIM data for every wall type. And so what we imagine here at Georgia Tech is that there's going to be a BIM wall builder application that builds these wall types automatically out of your product data and based on a certain pattern, running bond or stacked bond and mortar color, and then instantiates this wall in BIM instead of having to load, if you will, all of these wall types in at once and the architect parse through and see which one might or might not work for her. Here's just some BIM data from Endicott. This was one of the best BIM models we saw because it started to acknowledge the fact that we do lay masonry up in a lot of different and interesting patterns, and this is a way of facilitating the architect building composite BIM models in Revit. So again, this is part of our process is looking at and critiquing your BIM data and understanding a better way of getting your model and unit data into BIM. In the future, we're going to be dealing with stakeholders other than architects, and so what you can imagine is that we would love to work with you to develop those business process modeling notation diagrams for each of the phases of the process that involve you in the masonry supply industry. And we are imagining future states of BIM where things like the tracking of masonry units on the job site are possible. So here we see, we'd like to know when masonry was delivered, where it is on the job site, so that we can let the masonry foreman know that the materials are available. That specials like cast stone lintels might be tracked separately from the off-the-shelf products, so we know what size there are, and we might even be able to understand the requirements for installing them. So for example, if these cast stone lintels weigh 1,600 pounds, that might be something that we need to know to facilitate the installation of these special masonry units. What's coming up in the fall of this year, Jeff mentioned our second project. It's going to be the benchmark project, and we're actually going to be building BIM models to support various phases of masonry building design and construction. We're going to be working with the software providers and with you and with local masonry contractors here in Atlanta to develop the BIM models and query them. You might call it a virtual project, in that we're going to be acting as the design and construction team on masonry projects. We've developed 3 project types: a standard brick and CMU, a structural load-bearing masonry with precast plank, and what we're calling a complex masonry project that will probably have a lot of cast stone, custom elements, and maybe some unusual geometry. And we need your help. I think it's very important for us to interface with you. If you have questions for us or concerns about our project, we want to hear from you. And this last bullet, if you would be willing to have us come into your business to help document your workflows, order processing, material tracking, how you interface with your clients, architects and engineers, please let us know. We're going to be developing and publishing these business process modeling notation workflows for the industry, and as, if you will, as best practices, or at least as Georgia Tech's view of how information and materials flow in the industry. And we would like for you to be involved in our process. At this point, I'm done. I don't know, Jeff, are you on the microphone? Are you muted?
No, I'm on.
So we are available now to take your questions. And Tyler has been Tyler has been documenting your questions. The first question I have is not a question, and it says most sample boards are distributed by manufacturers, not distributors. So thank you for that. I think that's good. That actually is a great example of us needing to interact with you to better understand the workflows associated with each of these steps in the industry. So I don't know if MCAA, you want to unmute the attendees' mics now in case that there are those in our audience who want to ask a question directly. Jeff, are there any comments you'd like to make, or while we're waiting for questions?
Well, no, I guess the this is a big undertaking. I think, Russell, you did a great job of outlining the flow of what's needed, what's not out there. This is a complicated, it's going to be an expensive process, but we do feel it will be cutting out a lot of the labor costs. It will give us the opportunity to have more direct communication with the architect in terms of materials and participate in that design process. And we like the idea that the information is interoperable. It's connected to everybody, and we can be involved in that. So we need your help.
Good. I think there was someone who wanted to ask a question.
Russell, I've got a couple questions here that I can read to you.
Tyler, that would be great.
So the first question is Mark Pernicani. You haven't mentioned IFCs. How will IFCs contribute to the solution?
Thank you. So for those of you who are not familiar with IFCs, the IFCs are data models which are used to support interoperability between various softwares and phases of a project. I think what we do here at the Digital Building Lab is when we really understand a workflow and the software that are working, we develop specific, very, I would say, uh, holistic data models in IFCs, because all of the kind of open BIM softwares are going to be using IFCs for data exchanges. But at this early stage of the process, we are, I would call it, I would say, documenting more high-level workflows. And when we get buy-in from the masonry industry that we have a workflow correct, then we will actually develop an IFC for those given, say, sets of data about masonry units or masonry walls. Part of our software specification in phase 3 of BIM-M will actually be defining a schema for masonry walls, and those will be based on IFCs. I'm not sure if I answered that question completely, but thank you, Mark, for that question.
Next question we have is Charles. How complex is the building wall model? All components through full thickness of wall? How much will be modeled?
So that's a great question, Charles. I think that what we imagine is that there won't be one wall model. There will be multiple wall models with differing levels of complexity. And so what you might need, depending on your need to know, is that I've got, let's say, a region of wall that's 10 feet high and 60 feet long in running bond that I need to build today. And that's all you need to know. I don't need to know where every brick is. So there's one view, if you will, of the wall that is not very detailed. But if you're trying to do a photorealistic rendering of a wall, or if you're trying to automate a process such as cutting masonry units on the job site, then you need very detailed information about the wall, and you need to model it completely. And so what we, in the BIM world, we use a term called model view definition, which says that given my need to know as a stakeholder, what is the appropriate BIM model for my process? And so I think that we're imagining a masonry wall data structure that includes both very light, we call them models, which can be easily manipulated but don't have a lot of information, and very, very detailed models of masonry walls where you might, for example, need to see the flashing, or you might want to know if the weeps are going to work, or you might want to know, analyze how the relief angle is working and how thick the caulk needs to be beneath that relief angle. So it's a complex process, but we are developing multiple wall models, not a single wall model.
The next one comes from Sean Higgins. As a cast stone manufacturer, that mostly does custom profiles, what can we do to get involved in the process, and what type of information will we need to do to get involved?
So I think that, Sean, to the degree that you're willing to be open with us, what we would like to do is to come and sit with you for a day and understand the information flows in your industry. As a structural engineer and kind of junior architect, I can tell you that I'm familiar with the process from my end. That is to say that I would imagine receiving a lot of shop drawings, checking embedment locations, but from your end, I don't understand the cast stone process well enough. The fact that you're probably having to make shop tickets to communicate with your workers who are building formwork. You're having to order materials and get those materials in. And frankly, we've looked at some case studies of some very complex buildings, such as the Louisiana Sports Hall of Fame, which was a cast stone project. And we understand that some of these BIM-enabled workflows are going to be of tremendous benefit to your industry because of the likelihood that you have to recreate geometric data over and over again because you can't get it out of the architect's BIM model. So for you to get involved, you need to send me an email. We need to set up a time to come and see you. And I would say from your end, you would have to you'd have to be open with us and allow us to publish some of the kind of workflow models that come from your process, because we want to instantiate those in BIM. So that's the negotiation we need to make.
Up next is Bob Goldman. What about government standardization, fonts, nomenclature, etc., with programs like SPIES, S-P-I-E-S?
So in Europe, the Open BIM standard is really driving the development of IFCs that Mark Pernicone mentioned. That is to say that there's going to be a requirement in Europe that projects are delivered as IFC models, construction projects. And so there are going to be a lot of government standards for the naming of objects and the delivery of BIM models. The U.S. process is less regulated. We're working through the national BIM standards, and BIM-M has the chair, if you will, for masonry within the national BIM standards, but we don't have a common nomenclature other than, say, the Omni-class tables or some of the uniformat tables for naming masonry objects in BIM models. And that's a huge task for us here at Georgia Tech. It's actually the kind of core work that Professor Eastman does, is to understand building product models. And the future of these models, I'll just give you a scenario. The future of these models is such that you can imagine querying a BIM model that you didn't build to determine whether it had face brick on it or architectural block. So much like we used to access the drawings through the Dodge reports, or to try and figure out what buildings were being built with what materials, until we have this kind of common masonry classification system instantiated in BIM, it's going to be hard for you as masonry manufacturers to understand what's coming down the pike and how you might, let's say, get into an architect's office and say, I know that you've got a model showing a lot of face brick. I'd like to sell you that face brick. So that's one of the potentials for better BIM models of masonry. But we do have to have a unified classification system. I don't know if I answered your question well or not.
The next one is from Jim Stradley, and his question is, how would a supplier suggest early enough in the process for the properties and for the design to use a BIM model?
This is Jeff.
Go ahead, Jeff. Thank you.
Go ahead.
No, Jeff.
Well, what I was going to say is a lot of the information that we're passing on is going to be right in the Revit model itself, and so it's a matter of us getting that information to them. So that would be one of the assignments through the distributor, Jim, that you would have to take on, was to share that information, let them know the information is out there and get them involved in it, but that's not going to happen right away.
Let's see here. Steve asks, will architects be able to create custom shapes unique to their project and have them appear in a BIM?
The answer is yes. They're doing that already. In Revit, that process is a little bit ad hoc. The architects kind of have to fool Revit to put, let's say, a keystone, a cast stone keystone above an arch, because the wall definition in Revit, I don't want to get too technical, but the wall families don't really accommodate that very well. They kind of see a wall as being a continuum, and they represent rectangular openings like doors and windows pretty well, but when you think about some custom shape embedded in an otherwise running bond wall, Revit Revit kind of rebels against that because it doesn't know how to treat it. So again, what we have to do on the computer science side here at Georgia Tech is to develop a better data model for a wall, and then we have to convince Autodesk and others that our data model is worth considering for their next version of Revit. And there's a huge concern in the architecture community that Revit models are already really heavy. And what I mean by that is that when you pull up a big Revit model, it can take a long time to load, and it's really a lot of information for the computer-aided draftsman to work with. And so we have to come up with these multiple views of masonry so that if we have custom units in the BIM model, that it's not slowing the software down to the point where it becomes overly cumbersome. This is something that's going to be overcome with time and better computing power and a really smart data model. And again, that's something that not to be bragging, but we're really good at that part here at Georgia Tech. We have a lot of talent on Professor Eastman's side with these data models, and so we really are working hard on that. It's not really part of the model unit database project, but it's one that's coming up next year.
You know, this is Jeff speaking to Steve's comment too. When you look at, for instance, concrete block, we make structural brick, or even in a brick veneer where you're, let's say you've got one, say a 4-foot band of one color of brick, and then you put an accent band of another. You've got special corners now that maybe you have, let's say you're in a block and you've got a special bond beam every 24 inches on center. Revit doesn't want to look at those because those represent individual units, and now all of a sudden there might be 1 million pieces on a job, and you may have, you know, 20,000 of this color and this size, and you may have bond beams every so often and maybe a different texture. And if each of those are units, Revit doesn't want to look at that. They want to look at walls. Initially, they want you to create a pattern or a texture as a layout, or almost like you were going to paint a wall and give it a texture rather than an individual unit. So that's something we're going to have to work on because it does change the geometry of the wall system. Now all of a sudden just the wall element itself may have hundreds of thousands of units and thousands of shapes, and having to keep track of those individually. But that is something that we want it to do. We do need it to be able to tell us there are 25,000 bond beams, there are, you know, 150 corner units that are an L-shaped bond beam, and so on. So it's complicated, and it currently doesn't have the capability to handle that kind of information right now.
I think that's a really good question, though. But up next, Charles has, how would BIM handle an arch?
This is Russell. There's no problem. I mean, if you're talking about a geometric representation of an arch, I think that's something that we can model parametrically. If you're talking about the structural analysis of an arch within BIM-enabled software like Bentley RAM, I think that's a much more complicated question. But I think that there are already, if you go on the Revit kind of blogs, you will see architects and CAD designers already talking about how they quote-unquote fool Revit into representing an arch. But what's important to note is that you can convince Revit to display an arch in a way so that it looks like an arch in elevation for the drawing that the architect is still producing from Revit of the building. But if you query that data model and say, are there any arches on this project for which I have to order custom brick and or cast stone? The answer is no. There's not a data model for arches, and so it looks like an arch. When we see it in the model, we know that it's an arch. But if we use a data query, nothing like that would show up because there's not an inherent data infrastructure in Revit for an arch. So that's the limitations of the software at this time.
That's the last of the questions I have here.
Jeff, I'll turn it over to you for wrap up.
Well, I just want to say thank you to all of you who have taken the time to join us today. We hope that you'll be involved. We hope that if you have questions or comments that you would share those with us. We are looking for information, again, for the masonry material, or for the units. If you would like to join any of we have the cast stone, the concrete masonry, and the clay masonry groups. If you'd like to join one of those, send me an email at jeff.elder@interstatebrick.com, and I would be happy to assign you to one of those groups. Right now we're in a kind of a hold mode because we've given us enough information for Russell to get going on his, but as he gets a little further along in his work, I'm sure he'll be asking for more information. So right now we're just in a holding pattern, but we would love to have more people involved. Again, we thank you and wish you a happy holiday. Thank you.